Welcome to today's Explainer. We're diving straight into a really fascinating high-stakes micro-ecosystem playing out in, of all places, a backyard balcony pond. We're looking at part 309 of a journal called Notes on Fishkeeping by an aquarist named Ang. This is a closed-loop system where every single variable matters. And as you'll see, even the tiniest adjustment can trigger a massive, massive ripple effect.
We'll just have to wait and see. Okay, that is exactly how Ang signs off an August 6, 2026 journal entry. It's a pretty suspenseful note to end on, right? It immediately makes us ask, well, what exactly are we waiting for? What on earth happened in this pond that has forced the caretaker into this state of anxious observation? To figure out the mystery here, we have to rewind a bit and look at the catalyst that completely disrupted the balance of this little backyard habitat.
Shifting the microclimate. A sudden change. So, the central drama of Ang's entry begins with a seemingly simple decision, moving the outdoor pond to a brand new spot on the balcony. The core outcome of that move? Increased sunlight exposure. By just nudging its physical position, these aquatic plants were suddenly thrust into a much more exposed environment. They went from their comfortable baseline normal to dealing with a sudden, intense influx of solar energy. It's kind of like walking out of a dark movie theater right into the midday sun. And in any biological system, a sudden environmental shift like this creates immediate winners and losers.
Section 2. Survival of the frogbit. Adapting to the sun.
When variables in a microclimate shift, life has to adapt and fast. And one species in Ang's pond rose to the occasion beautifully. Meet limnobium-laevigatum, or as it's much more commonly known, the Amazon frogbit. According to Ang's notes, after the sunlight increased, these little guys didn't just endure the new intense sun, they actually started to acclimate to it. It's a really fantastic example of environmental resilience happening in real time.
Section 3. The Salvinia setback. A tragic casualty.
But, unfortunately, nature is rarely a story of universal success, is it? While the frogbit thrived, we have to look at the tragic casualty of this microclimate adjustment. Say hello to salvinia-minima, the common salvinia. Ang reports a completely different, frankly devastating outcome for this specific plant. Following the move to the sunnier spot, the common salvinia entirely wilted, every single one of them. They just couldn't handle the shock of the new, exposed environment.
So we are left looking at this incredibly stark contrast. On one side, the Amazon frogbit totally acclimated to the aggressive sunlight. On the other side, the common salvinia completely wilted. Think about it. They shared the exact same water, the exact same balcony, the exact same environmental shift, yet their biological responses were absolute opposites. This contrast is exactly what makes managing a micro-ecosystem so tricky.
And that leads us to the core mystery that Ang is actively trying to solve. Is this new microclimate actually suitable for common salvinia? It's a great scientific question. Like, did the intense sunlight directly kill these plants because they inherently just can't handle it? Or, actually, was it just that they failed to survive the rapid, stressful transition, the shock of the move itself?
Well, instead of just guessing, Ang came up with a really smart plan: replace all the wilted common salvinia to properly evaluate the suitability of the microclimate. It's essentially running a controlled backyard experiment. By putting fresh common salvinia into an already established sunny environment, Ang completely removes the variable of that sudden shift. If the new plants die, boom, the environment is definitively too harsh. But if they live, then the original plants merely died of shock. It's an incredibly effective way to test the actual viability of this habitat.
Section 4. Attack of the algae. An unintended consequence. Just as Ang was setting up this next phase of the experiment, the ecosystem threw a massive curveball. Let's look at the biological chain reaction that went down here, because it is literally a textbook butterfly effect. Step 1. You have your increased sunlight exposure. Step 2. Debris from the wilted common salvinia starts breaking down in the water, which provides a ton of excess nutrients. Now combine intense light with heavy nutrients, and what do you get? Step 3. A massive algae bloom. Ang notes that the outdoor pond is currently choked with this exact issue. Moving a pot a few feet to the left directly resulted in an aquatic algae takeover.
Section 5. The recovery plan. Restoring equilibrium.
So, how do you fix a system thrown completely out of whack? Let's explore Ang's strategy. First, allow the surviving aquatic plants, like our incredibly resilient Amazon frogbit, time to naturally colonize the surface of the pond. Second, execute drastic water changes to manually remove the excess nutrients and algae. And third, wait and see.
Now, the sequencing here is absolutely crucial. You can't just panic and start ripping the ecosystem apart. You have to let the foundational pieces establish themselves first.
Ang hits the nail right on the head here, writing drastic water changes in the future, once the aquatic plants start to colonize the surface, should mitigate this issue. The magic word there is once. Notice that Ang isn't doing drastic water changes right now. Ang knows that the aquatic plants need to colonize the surface first to naturally block the sunlight and outcompete the algae for those nutrients. Only then, in the future, will Ang intervene with water changes to clean up the rest. It shows an incredible amount of patience in ecosystem management.
And you know, this brings us full circle to a pretty profound takeaway that applies to way more than just a backyard pond. Think about it. When you're managing any complex system, whether it's a tiny microclimate on a balcony, a massive project at work, or even trying to build a new habit in your own life, when is it time to step in and take drastic action? And when is it best to just step back and let nature colonize? Ang's experiment shows us that sometimes before we rush in to furiously fix the algae blooms in our own lives, we need to make sure our foundations have actually had the time and space to acclimate, survive, and establish themselves. Because sometimes the absolute most active, powerful form of management is simply having the discipline to wait and see.